A histogram is a very common way to display numerical data. So suppose we're given this frequency distribution, or you had a list of data representing the number of defects found per hour in items at a manufacturing plant. So whether you went through and created this frequency distribution that I have on the right-hand side, or it was given to you in this format, you can create a bar graph, okay, which is called a histogram, for that numerical data. So it looks like we had anywhere from 2 to 12 defects show up per hour. And the F column represents the frequency at which those number of defects occurred. So a bar graph or histogram is a very straightforward way to display that distribution. So the number of defects, your X always goes across the bottom on your horizontal axis, and the frequency always goes on your vertical axis. Now sometimes when you look at a frequency histogram, it's hard to tell exactly what the scale is, so how high each bar is, so the frequency in each bar. So sometimes you have to kind of estimate. I estimate that first one to be 2 high, and then the next one to be 16 high, and so on. So the way you would read this bar graph would be, you would expect 2 defects to occur about 2 times. You would expect 3 defects to occur about 16 times, and so on. Okay, notice they don't label every single bar on this one, whether it's to keep it more neat or they just chose to do that. Okay, it's hard to know, but if you're trying to figure out what the scale is, this one is pretty straightforward in that you have 2 and then it skips the bar and then goes to 4. So it's pretty easy to tell that that should be 3 there and then 5 here and so on. Okay, the next example gives us a histogram where now we're looking at intervals rather than a discrete number of values for X, so 2, 3, 4, 5, and so on. Now our X values are representing the scores on a psychology exam, and the data would have been much wider or much higher range. So now we're using intervals rather than listing out every single data value in the X column. So anybody who scored between 40 and 49 points is represented in this first bar. And how this one is a little bit different, when you look at the boundaries or the endpoints of the intervals, what they do is they label 39.5 and 49.5. So assuming you can only get a whole number, okay, meaning a non-decimal on the score, that interval from 39.5 to 49.5, so those boundaries would include anybody who scored between 40 and 49 on the exam. The next interval, 49.5 to 59.5, that would hold any values for anybody that scored between 50 and 59 on the exam. Okay, so this is using the boundaries or endpoints, and one of the reasons they do this is because a histogram, the bars should always be connected. And if you just tried to put 40 to 49 and then 50 to 59, if you just tried to label that down here on the axis, what that would do is from between 49 and 50, so where that first interval ended and the next interval starts, there's a gap there of a 1. So what would you label the end of this first bar? Would you label 49 or 50? So that's the problem, is that you wouldn't know what to label it. Okay, so the 49.5 allows you to label that bar at each of the endpoints, and you can determine from there what values would actually be included in that first bar or the second bar and so on. So that's why they use boundaries or endpoints to label axes. Okay, so those are 2 examples of histograms. There are several different things, different histograms you may see between changing the axes or changing the vertical, the y-axis or the frequency axis. Okay, so there's so many different kinds and so many different examples. These are just two basic cases. Okay, the first one where you're given a discrete number of values for x, like 2, 3, 4, and so on. And then the next one using intervals to create your bars.